Now, no discussion about the architecture of MariaDB is complete if we don't mention storage engines. Now, the actual thing in MariaDB would be like plugins. So MariaDB is based in plugins, and you have plugins for security, for logging, for auditing, for even for sending feedback to the MariaDB team, I think, and I don't know what else, but a special kind of plugin is called storage engine, and there are multiple. So for many years, we used general purpose databases like Oracle and even Postgres. And these databases, they have one storage engine that it's general purpose, just one storage engine, and it's for all use cases. This has the advantage that what's simplicity, right? So it's easy to understand. We just have to use one database. Done, we're done. That's cool. But then they are not specialized. And as the internet became a thing, we got concurrency, right? So more and more users. So workloads started to change a bit, and new databases started to appear to cover those cases. So for example, we have Cassandra for write-heavy workloads, MongoDB for scalable. I'm not saying that MongoDB is the most scalable database at all, but I'm using it here as an example, right? And Vertica for analytical workloads. These databases, they have their own storage engine, and it's specialized for that kind of workload. Now, the cool thing here is that, well, now we can handle those cases. That's great. But now we have introduced quite a lot of complexity because each one is a different product developed by different companies, by different teams, different licenses, different pricing models, different kind of vocabulary, different kind of technologies, tools, ways to connect to them. It gets complicated, right? Different quality levels, right? So complexity increases even though we are now able to handle these workloads. MariaDB, on the other hand, is pretty cool because it's just one single thing developed by one team with one set of tools, etc. And it has all these different storage engines for different kind of workloads. So on top of that, we put a SQL layer or module. And now we have the best of both worlds, really, because we have a general purpose database. So we are dealing only with one kind of technology. And yeah, each storage engine has its own things, but we know that it's going to work more or less the same. And we have only one SQL layer. When we connect to MariaDB, we use the same tools that only one set of tools. And we have the multiple purpose built storage engines, which are also pluggable. We can install more or remove some if we don't want them. Best of both worlds, really. So let's focus on the storage engines. And in MariaDB, each one has a different name. Okay, these are not all the engines, but it gives you an idea of what's available, right? That's the purpose of this webinar. We have, first of all, InnoDB, which is for mixed workloads, what you're going to use most of the time, really. It could be used, for example, for inventory and customer profiles. And these are just examples. It depends really on your application, but just so that you get a rough idea of what this is for. We have MyRocks, initially developed by Facebook for write-heavy workloads. This is good for example, clickstream and purchases. Spider, which is more of a virtual storage engine for scalable workloads. For example, shopping carts, cookies, that kind of stuff. I say that it's virtual because it doesn't really store data as such. It kind of delegates to other instances of MariaDB, so you can scale horizontally by partitioning the data, something called data sharding. Now we have also column store for analytical workloads, for example, maybe recommendations and offers, all these inside MariaDB. Now let me show you an example here. Let's say we're building an application and we expect tons and tons of comments. Now we can say create table comments, define some columns here. I'm gonna omit that part. And then we say engine equals MyRocks. Done. This table is optimized for write-heavy workloads, so we're gonna save a whole lot of money on storage. That's actually the use case that Facebook faced when they were creating MyRocks. Now it's available inside MariaDB. Cool. Now, on the other hand, we might have another table for categories, and those categories almost never change. Or maybe they change, we add a new category every year or every 5 years or whatnot. We're not writing a lot here. But on the other hand, we are doing the opposite. We are reading categories from everywhere in our application. So tons of reads. So there's another engine that I didn't show in the previous diagram, but it's called Aria. So we can say engine equals Aria, done. This is now optimized for reads. Aria here comes from Maria without the M, by the way. Okay, but the cool thing is that this is in the same server. So we can create a query that's select all the columns from the comments table and then join that with categories. I'm not showing all the details of the code here. Join, remember the primary key and foreign key again. We're connecting data somehow. That would be there in the part that I'm not showing, but you get the idea. We're mixing the data so that we know the comment to which category belongs, for example. And now this is just one single query. Now we are combining two storage engines in a single query. That's not possible with other databases. That's not possible if you are using several databases for several, different kind of workloads. You will have to join the data manually in your application code probably, which adds a whole lot of complexity. So this is a powerful, unique feature in MariaDB. We call it cross-engine joins.